Um, yes. All right, so just real quick before I dive into things, you can access all of these slides at go.mdb.dev/graphic slides in case you wanted to follow along or refer to these after. And I'll have the link up at the end as well. So yeah. To start off, a bit of an intro about myself. So hello, I'm Shubha. I'm currently a master's student and I'm studying EECS here with a concentration in visual computing and computer graphics. I got really interested in the field of animation, specifically like feature films, after interning at Disney Animation Studios. And I just was really interested in computer graphics as a means to intersect technology with physics and math and the arts. So I thought it was really cool that you could be an engineer and also work with creative people on artistic work. So this is kind of the path I've chosen in my technical career. And yeah. So a bit of what I'm going to talk about today. I want to very briefly cover some history about how 3D animation became a thing, just so like you guys can get a glimpse of how closely intertwined the field is with technology. So arts and technology in the realm of 3D animation have pretty much been developing simultaneously, and one drives the other. And then after that, I want to actually go through making an animated movie. So I'm going to go through the end-to-end pipeline of how an animated movie is made and kind of cover a little bit about every stage in the production process. And then right after that, I will talk about the modern frontier of computer graphics. So this is really just looking at where and when innovation happens within this field. And then lastly, I'm going to cover a bit about technical careers in animation. So this is something I personally was not super aware of as a Berkeley student, but there really is a very wide range of technical roles available in animation studios outside of just your like normal software engineering roles. So I'll talk a bit about that. And in the end, I'll have a couple of minutes, hopefully, for a Q&A. And throughout, I will be basically dropping some tips and useful resources where if you are interested in pursuing this field as a career or learning a bit more about it, hopefully like you can use these resources and tips to get more involved in the field. All right, so with that, let's start out with a brief overview of the actual history of how 3D animation came to be a field. All right, so this slide is a lot, but it's covering, you know, a lot of history. Humans have basically been trying to capture motion through images from the very beginning. We can see like in cave paintings even some key tenets of 2D animation and capturing elements of motion through pictures. And then the second image is actually something called a phenactoscope. And it is the first widely used animation device. And it's kind of limited to only show a continuous loop. But this was considered to be actually one of the first forms of movie entertainment. So after this was a thing, humorous faces of funny faces is actually a very historic film because it was the first 2D animation drawn an actual movie film. So technically it's the first animated film, and this was created in 1906. Right here on the bottom left is Steamboat Willie, which some of you might actually recognize because it's the intro to Disney animation films, and it was created in 1928 and was historic because it was the first animated cartoon to synchronize visuals with actual audio that matched the film. And then lastly, you know, you guys are probably a little bit more familiar with, you know, the rest of this. So Snow White and the Seven Dwarfs, released in 1937, was the very first animated feature film and it basically kickstarted Disney. And after that came what's known as the golden age of animation. And here's just a slew of classic Disney movies that came in this era. So in the 1960s, actually, that was when computers started to enter the mainstream. And in the 1970s, graphics moved away from being confined to science and research laboratories and actually into the arts. So really, like, not very well-known fact is that the University of Utah, pictured up here in the upper left, is pretty much the center of computer graphics innovation, because they established one of the pioneering computer graphics programs where you can pretty much trace almost every influential person in the early years of graphics to this program. So some people include the founder of Adobe, John Warnock, and founder, president of Pixar, Ed Catmull. And right here is the Utah teapot, which is one of the inside jokes in computer graphics. It's often used as a test asset to test out material properties, lighting, and things like that. And all of that stems from this University of Utah program. Over here is Ed Catmull's film in 1972 called Hand Face. And it was really pretty much the first 3D animated film, like the first of its kind. And it was groundbreaking and used in a lot of very famous movies, just because people thought, like, wow, this is so cool. We want to showcase it somehow. And then, of course, many of you may be well acquainted with Jurassic Park. A lot of really prominent people in graphics point to Jurassic Park and say, this is when I realized that 3D graphics was my calling. So this is where 3D graphics was actually showcased in a film, and people realized the power that it could potentially have. And lastly, here I have Star Wars, because in honor of George Lucas, founder of Lucasfilm and creator of the Star Wars franchise. And he was really pioneering in that he was a filmmaker who really embraced the power of melding technology and artistry through film. So he actually hired Ed Catmull, who created this hand film, and Ed Catmull led a division in Lucasfilm dedicated to this art tech intersection, and that division was what spun off and later became what we know today as Pixar. So Pixar was originally a company which just sold really high-end computers, and these computers could be used for the filmmaking process. Steve Jobs originally purchased it for $5 million from Lucasfilm and strove to make it a company based on the Pixar image computer, which is pictured here on the left. So this is actually when Steve Jobs got kicked out of Apple, and he was looking for his next thing. He was working on a computer company called Next, and he just saw Pixar as another computer company. However, Ed Catmull, who was the technical lead for Pixar and is pictured here, really had this film, this idea that he wanted to create a feature film made out of 3D computer graphics. And this was basically his dream. And eventually they hired this really talented Disney animator named John Lasseter, who eventually became a very famous director. He directed Toy Story, and he was also chief creative officer for Disney for a while. And together they were the dream team that founded and grew Pixar to be what it is. So that was the beginning of Pixar. And I'm focusing this much on Pixar because Pixar is basically where most of this field of 3D graphics has been established. So you can literally see the evolution of graphics and art driving each other in these early films. So on the top left here is a short film called The Adventures of Andre and Wally B. And you can see it's literally created out of like spheres and cones, the most basic shapes. But what they learned through this film was even if your graphics are really bad. As long as you have a riveting story, people will be pulled in and will continue to watch the film. So that actually is like one of the key tenets of Pixar. They say story is king. So yeah, that is the first animated film, 3D animated film to be made. Following that was Luxo Jr., which you guys might recognize these lamps from Pixar's iconic intro. And then here is a film called Gary's Game. If anyone from Berkeley has taken our computer graphics course, CS 184, this was the first case where the subdivision surface algorithms were utilized. And of course, the rest is history. So we have Toy Story, which was the first ever animated feature, 3D animated feature film. And it was released in 1995. And after that is Bug's Life, which I included because Bug's Life was basically the movie that spurred a lot of new technologies in clouds. So they had to animate like hundreds, thousands of ants maybe. So that's where they basically developed the crowds team, which is core to a lot of animation studios nowadays. So just an example of how technology feeds art, feeds technology. This was also kind of the end of 2D animation, which is kind of sad because we don't see a lot of 2D animated films nowadays. But you know, a lot of the tenets of 3D animation are built off of all of the things that we learned in 2D animation, and I do hope that it like continues to stay a thriving art, you know, in the future. But now we really consider 3D animation to be king. So here are just a couple examples of the incredible animated films that are released in the modern day. And all of this is really based on the foundation laid down by 2D animated films, by Ed Catmull, and by other pioneers in the field of computer graphics. So if this interests you at all, I have a book recommendation, Creativity Inc., which I'm currently reading, and it's basically about how Pixar came out to be and all of the birth and growth of the field of computer graphics. And if you don't like books, I do recommend this documentary called The Pixar Story, which is on Netflix. All right, so with all of that homage to the history of 3D animation, now I want to actually dive into what goes into making a 3D animated movie. All right, so this is what's known as the pipeline. And the pipeline can be basically split up into 3 separate parts, which is pre-production, production, and post-production. So pre-production basically consists of the ideation phase and the design phase. So it's a lot of putting together the story, the script, and designing all the characters and the asset and the aesthetic of the film. And then from pre-production, you move into production, which is the process of actually building piece by piece every element that goes into the 3D animated film, and putting that together to make the film, essentially. And then post-production is after the film is made, maybe making some final touches. So compositing is part of that final touch process. And then also this is when video and sound is added in. And also post-production consists of things like marketing and distribution, but I haven't included that here because I'm only going to cover things that are central to the actual making of the film. So this is the pipeline. And with that in mind, let's dive into the pipeline, and I'll be illustrating all of these pieces by pulling from hopefully some of your favorite animated films and showing how they were actually made. So pre-production consists of story, script, and concept art, which is basically creating the actual story and what people say, as well as the overall feel and aesthetic of the film. This moves into storyboards and animatics, which I will cover a little bit more in detail as well. Okay, so while the story and the script is simultaneously being developed, concept art is like a really key part of this pre-production process. Concept art is essentially paintings done by actual painters. So this is, I guess, what sculpting and oil painting majors do. They basically captured the sets and the colors and the characters and the overall feel of a movie. So this is a really great example of how in Pixar they captured the feel of WALL-E. WALL-E is a movie with a dystopian vibe, but the message is also about nurturing life and finding beauty in and reviving a destroyed world. So you can kind of see the sense of curiosity and hope the artists have captured through these concept art. And in contrast to that is some concept art from Ratatouille, which, as you can see, is a very, very different vibe, very lively, lots of color. And I feel like the artists were probably also, really inspired by Impressionist paintings, like here in constructing this. So people just really have fun with it and want to capture the vibe of the movie throughout whatever means that they have in these art pieces. Okay, so after concept art, or I guess somewhat simultaneously, is the creation of something called a color script. So this particular color script is from the movie Ralph Breaks the Internet, which is the second Wreck-It Ralph movie from Disney Animation. And color really defines mood. And you can see through this color script how mood varies throughout the film. So this actually serves as a guide for the artists who work on the production pipeline after the whole pre-production process. And it really allows for people to maintain a consistent mood in their work if they're working on a specific scene. So yeah, you can see just the power of color. Like here, you see the dark greens and blues. Here you see kind of the gold and the pink. And that marks basically the separation of scenes and settings in this movie. Okay, so one thing I thought was really cool once I actually learned about it and started looking for it in films is this process of character design. So basically, like all of the characters made in animated movies, or most animated movies, have design where they're based on essential shapes. And every piece of design in these movies is used to tell a story, and you can see that through these shapes. So square-based characters are typically representative of stable and stubborn characters. And then people with circular bases are generally friendly and soft in their personalities. And triangles are used to represent kind of active or dangerous characters. So you'll actually see a lot of villains in animated movies are triangle-based. So let's do a quick exercise. Take a couple of seconds and try to spot all of the basic shapes that make up these characters. All right, so that was a quick couple of seconds, but if you hadn't seen it, here we go. So this is Carl from Up, who is in the beginning of the movie extremely stubborn and set in his ways. And you can see how much they've incorporated just the square shape into his design, starting with like his face, but also moving into even his fingers and his nails, the couch, the glasses he's wearing. Everything is square based here. In the middle, we have Joy from Inside Out, who is a very kind of happy, friendly character. And so they've made her a circular base for her face. But also, I kind of noticed like there's a little bit of a triangle in her hair. And I think that is pretty intentional because she's kind of like a hyper character. And we said triangles are active characters. And lastly, on the right, we have Anton Ego from Ratatouille. And Anton Ego is pretty much entirely triangular based, from his like body shape to his nose, his cheekbones, and even the little crooks of his fingers are very sharp. So yeah, this is one of those like nonverbal ways that storytelling works in character design. So after character design and the actual creation of the film, storyboards are used to capture basically the key moments in the film. And these are pretty much low fidelity, very crudely drawn images, crudely drawn for, I guess, talented artists. But the entire point is to capture the story and emotion of the film while also allowing for artists to redraw and iterate as quickly as possible. So once you have these storyboards for like key frames, storyboards come together as a sequence to create what's known as a animatic. And a lot of times at this stage, there are also like something called scratch recordings or rough recordings of the voice acting being made. So these voice recordings are paired together with the animatic to give a more complete sense of the story through both visuals and sound. And also at this stage is when they actually start previewing the film for, you know, famous directors or prominent writers, just to get feedback on the film. And this is actually equivalent to, I would say, like the low fidelity prototypes that we use in tech for feedback on our ideas. So I thought this was really interesting because we see how key even having these low fidelity prototypes for user testing is in the animation industry. So pretty cool. All right, so now that we've covered like some of the major elements of pre-production, let's move into the production process, which consists of modeling, shading, rigging, animation, lighting, rendering, and VFX. So let's quickly go through each stage. So modeling is essentially creating the 3D shape of objects needed in the film. So modeling can include assets like this car pictured here, or even characters are modeled through manual creation. And typically in the industry standard is people use Autodesk Maya, which is the software pictured here. After modeling comes shading. So shading is adding the color as well as the texture and materials reflectance properties so that you can go from just a 3D model to a full functioning multi-colored, multi-materialed object. And from there, you move into rigging. So I think this skeleton is a pretty apt representation of rigging because rigging is basically adding in the joints and controls for characters or objects that need to move. And this makes it really, really simple for animators to just move controls a little bit and adjust the way that characters move very quickly. So after rigging comes animation. So this is actually the animation interface, which animators use for facial animation. And I've always thought it was a little bit terrifying, but it's a very useful interface for basically building facial expressions of characters. So usually even before a movie is made, animators go in and they define what are some key facial expressions. So like, what does Maui look like when he's mad? What does Moana look like when she's like, I don't know, feeling smug? So even before the actual movie is made, animators go in and basically construct the quirks and personality traits of characters through modeling their various facial expressions. And lighting is a really, really magical point in the film. So this is from Big Hero 6. And up till now in this production pipeline, this is what the movie looked like. So everything's there, but it's pretty lifeless. So I think of lighting as basically breathing life into the film. Lighting can really be used to tell a story. In this particular instance, I think the warm color, as well as the very intentional focus on the characters to draw the viewer's eyes it's all like very well thought out to create the ambiance of this particular scene in Big Hero 6. And just as another example, here is some of the lighting that was done for Finding Nemo. And this movie presented obviously some really different challenges because they are modeling lighting underwater. And in order to accomplish this, the lighters had to understand a lot of physics and properties of how light behaves when passing through water and onto the seafloor. So that's how they arrived at this specific lighting situation. And if any of this interests you, lighting specifically, I would definitely check out Danielle Feinberg's talk on the magic ingredient that brings Pixar movies to life. It's a TED Talk, and she talks all about this process of coming up with lighting for Finding Nemo. Okay, so VFX, which stands for virtual effects, is essentially doing all of the simulation for creating effects like smoke or water or explosions in these films. So I chose this particular frame because the Nock, which is the water horse from Frozen 2, is actually a really interesting and complex example of the application of virtual effects, because they have to simulate basically how water behaves within water and make it clearly visible. So I went to a talk where they talked about how they accomplished this, and there are basically 8 to 9 layers of effects happening to make this horse look the way it is. And it's really a cool stage where there's a combination of a lot of computer science and physics elements with artistic elements. So yeah, VFX. And I think with that completes the production process. And lastly, from production, we move into post-production, which I mentioned earlier is compositing, as well as video and sound for film. So the coolest example of compositing I could find was actually Ratatouille. So this is a scene where Remy, the rat from Ratatouille, moves out of the sewers and realizes he's in Paris, and he looks out on the city. Just creating this background in with 3D computer graphics would have been an insanely computationally heavy task. Not to mention, like, it would take an insane amount of manual effort to model every building, to model the Eiffel Tower, to add in all the lights. So to circumvent that need to create this very complex background, they actually have painters create something called a matte painting. So this is a 2D painting that they have added in front of Remy, who's a 3D character looking out into Paris. And this is just an example of how there are a lot of ways that in the animation industry, they try to circumvent having to do these computationally heavy things and accomplish things with the maximum result with the minimum resources. So that's compositing. And I think with that, we finished going through the entirety of the pipeline. So I will move into the third part, which is discussing basically the modern frontier of computer graphics. So where are we today? How does innovation occur? And what drives innovation, essentially? So in any animated studio, there is some equivalent of a production technology team. These are teams of engineers who are specialized in very specific computer graphics or like software engineering areas that work with the movies. So I've just listed some of the main ones here. Hair and Cloth is a very prominent team because both Hair and Cloth actually act very similarly. They both act as what are known as mass and spring systems, meaning you can basically model them as a bunch of masses and springs colliding with each other, colliding with the world. So since those challenges, technical challenges, are kind of shared, they're grouped together in a Hair and Cloth team. And then you have the environments team. So they work to create the beautiful environments used in 3D animated films. A lot of times this involves procedural generation because environments can stretch out or stretch out to be very large. They can be extremely complex. So individually modeling something like every single tree in a forest is very difficult. So environments teams have tools like plant growers, which they use to grow trees, grow plants, and populate forests, for example. And then we have crowds, which I mentioned earlier was established basically through Bug's Life. Every movie that has a lot of people in one place, like a large amount of people or a large amount of characters, needs a crowds team because that's work that's also very difficult to do manually. So yeah, you need a technical team to do that. And then simulation is all of the kind of water, smoke, explosions. You have teams that are very, very mathematically, mathematically trained and very involved with physics. They do a lot of implementing papers that simulate how various substances, interact with the world and just implement that for the movies. And then lastly, I have pipeline infrastructure. So the pipeline I mentioned earlier has, it basically requires a lot of finagling to maneuver having various like file formats or artists need ways to store and access different assets in their film. So pipeline infrastructure basically is the ribbon that ties together all of the tools that are used in the production pipeline in animated film. So I kind of categorize innovation into two separate categories. One would be movie-driven innovation, and the other would be kind of research-driven innovation. So what characterizes movie-driven innovation is that it's very attached to the needs of an actual film. And here are some examples. So on this upper left, I have Moana. And Moana, if any of you have watched the film, is very involved with water. So there was a lot of innovation for water because water is something that you want to simulate the physical properties of it, but also you want to allow artists the artistic freedom to manipulate the water to be able to do things like float in the sky and separate in parts. So Moana led to a lot of water simulation research. In the middle, I have Hank from Finding Dory. I believe it took Pixar animators something like, or Pixar technologists something like 1 to 2 years to even create Hank. And the reason behind this is his rigging. If you remember, rigging is the process of creating controls for the various joints in the movement of the character. So his rigging was insanely complex. And in order to actually get a realistic representation of how octopi move, they had to spend 1 or 2 years doing rigging innovation, basically, to create this one character. Right here, I have Merida from Brave. So if you've ever noticed, a lot of Pixar characters, they don't do very complicated things with hair. A lot of times their hair is like stick straight. I'm thinking like Edna Mode or something from The Incredibles. But Merida was the first character where they had massively challenging hair to simulate. So they created actually a new hair tool called Taz, which won a Academy Award for like the SciTech Awards this year. And yeah, they were able to do this complex creation of Merida's hair and allow for artistic freedom for artists to modify it as they needed. And then I have Frozen here for the insane amount of snow simulation research that went into it. Snow is actually really difficult to simulate because it's, material properties are variable. So snow can be packed and made solid. Snow interacts with snow very uniquely. So yeah, Frozen led to a lot of snow research. And right here, I have the forest from Frozen 2. So this forest, as you can see, the trees don't look like trees you've probably seen. They're very artistically enhanced. And what happened was artists drew what they wanted these trees to look like first, and they handed it off to computer scientists and said, procedurally generate some trees that look like this. So it took a lot of tweaking to actually modify parameters and grow this forest of trees as the artist envisioned it for the movie. So this is a prime example of environments innovation, where procedural generation was used to create the actual set. And the second category of innovation, I would say, is research-driven innovation. So this is basically innovation that's separate from any movie. And this is just like an image from a procedural generation paper. I found there's a lot of innovation happening in parallel and distributed computing because graphics is a very, very computationally intense task. So they need things to be done faster. They need things to be done efficiently. So there's a lot of research in that area. I have this image included for real-time rendering, which is a very popular area of research currently. Real-time rendering is basically the process of creating a rendering or a 2D visual of a 3D model or something very quickly, almost instantly. And this is actually applied in a lot of AR, VR applications, which is obviously an exploding field. So this is why real-time rendering is very popular nowadays. And then right here in the bottom left is from a using machine learning for denoising application paper. And machine learning is basically like electricity now in a lot of, it's driving a lot of computer science innovation. So this is just one example of how, like, if you have very limited time to render a film, you end up with a very noisy image. And you can actually use machine learning to create a smooth representation of that image. And I can imagine this would be so useful for artists who are trying to animate and visualize their work real time. So that is machine learning. And if you're interested in learning a bit more about this graphics research, subtle plug for ACM SIGGRAPH. So SIGGRAPH is the main research conference on computer graphics that's held every year. And you can actually get involved in it as a student. So SIGGRAPH takes applications for student volunteers who, you need to contribute a bit to the actual conference, but you also get to sit through a lot of talks and, network with interesting people in the field. Yeah, so I would definitely check out SIGGRAPH if you're interested in computer graphics. And lastly, I wanted to talk a little bit about innovation being done with new mediums of storytelling. So mainly like this is VR, because that is a major up and coming field nowadays. So here are just some examples, like DreamWorks has its own VR project going on. Obviously, like Oculus is like a really prominent player in this field. So this is Facebook's VR sector, and they've actually created a lot of Emmy award-winning VR films. And then here I've included Cycles and Myth, which are two VR movies created by Disney Animation Studios. And Disney Animation very recently established a VR sector within their company. So I really think this is like a up and coming field. And who knows, maybe in the near future, we'll all be going to movie theaters and wearing our VR headsets and watching some cool VR movies. So yeah. So with that, I wanted to wrap it up by talking a little bit about technical careers in animation. So within animation studios, I kind of pieced out that there is this spectrum, I like to say, of technology to art. So on the furthest end, most removed from individual movies is research scientists. So every animation studio has like a small team of research scientists that are basically charged with staying up to date on all of the research being done in SIGGRAPH and seeing how that can be applied to the actual film. They also do mainly a lot of like math library things, going from papers and equations to trying to implement some kind of prototype of them. So research scientists are pretty removed from movies, but they're also given a lot of freedom to explore what they think would be interesting and useful to the studio. And then you have software engineers. So software engineers are also kind of semi-removed from the movies. They work on overarching tools that are used for like all films, essentially. Maybe if a specific film needs a lot of water simulation coming up, they'll build some new tools for water simulation. But they don't work specifically on like Moana, this shot, this scene. They're kind of more removed from the films and a little bit closer to like what research scientists do almost. I've seen that a lot of software engineers have like PhDs and do kind of researchy work. And then I have technical directors here. So technical directors are also known as TDs, and they're essentially engineers that are assigned to movies. So they work on specific scenes, specific shots, and basically in the beginning of the making of a movie, they vet, looking at what this movie needs, what kinds of tools should I build to help artists out. So they do a lot of like building out individual tools to enable a shot to be made. And they also pair a lot with artists. So they're partners with artists basically on the film in accomplishing the creation of certain scenes. So that's technical directors. And then VFX, I mentioned earlier, a lot of VFX people actually have computer science degrees. So it's an important technical role, but also they do have more of like an artistic aesthetic eye that they need to create the aesthetic elements needed for a film. And then over here, closer to the art spectrum, I have technical artists, which are mainly artists who have elements of technical work. They might need to know how to write scripts and code. They might also need to know a little bit about physics and math to be able to enable the creation of complex lighting and crowd scenes. And lastly, we have animators and concept artists, which are closer to like the pure artist work you think of, like painting, drawing, sculpting. So that's the tech art spectrum. And just to briefly like provide insight into the kind of companies like I would be looking at if I were interested in this field. So over here on the far left, I basically have all of these companies which fall under the umbrella of Disney. Walt Disney Animation Studios, Pixar are both focused on 3D animation. Lucasfilm, Marvel, and ILM do a lot of 3D graphics within live action films. So a lot of their work is based on simulation or motion capture of characters and recreating recreating these motion capture characters. And then outside of Disney, I'd say the main animation studio that releases a lot of feature films is DreamWorks, which is known for things like Shrek and Madagascar, quality movies. And then I included just some general studios. So Studio Ghibli, very famous, Warner Bros, Sony Pictures, Cartoon Network and Nickelodeon do a lot of TV animation, which is also starting to dip its toes into the field of 3D animation. And on the bottom here, I have some up and coming streaming services. So I think with the increase in popularity of streaming, we're seeing the creation of a lot more opportunities for people involved in 3D graphics. So Netflix very recently established Netflix Animation Studios. And I believe that, as Apple and Amazon basically become more established streaming services and need to create original content for different like market segments, they will also, follow the trend of Netflix and look into creating their own animation studios. So that's with, animation specific companies, but there are also a lot of non-animation graphics companies, which include any company that does AR, VR, where I've included Google, Microsoft, Facebook, and Apple here as the representatives for AR, VR. There's also a lot of cool graphics applications in the world of design and enabling really fast prototyping. So Figma and Adobe are some major players there. If you're thinking hardware, NVIDIA is probably the biggest player in hardware used for the purpose of graphics. And lastly, for gaming companies, I've added Electronic Arts and Blizzard, but obviously there are a lot of gaming companies that are very focused on the field of 3D graphics. So yeah, that is all of the companies and kind of career related things. If you are a Berkeley student, subtle plug, I wrote this Medium article to talk about navigating computer graphics at UC Berkeley specifically. And I think that's pretty much it. So I wanted to allow for like a couple minutes and I'll answer any questions that you have. But apart from that, thank you guys for joining, and yeah, pleasure to have you here. So yeah, feel free to like unmute yourself or pop questions in the chat if you do have any. All right, so Kanyas has a question. Within all of the graphic stuff you mentioned, what's your area of expertise and why did you choose it? So that's a really good question. I feel like I'm currently at a stage where I'm exploring really, but if I were to pick an area of expertise, it would probably be rendering or a lot of like real-time rendering. And I didn't specifically choose it. I kind of fell into it because I've done a lot of stuff with AR, VR, which is really prime for a lot of rendering innovation. And I'm also planning to work on a rendering team after graduating. And I guess like a reason why I think this would be really useful is rendering is very applicable to a lot of fields. So even outside of the animation studio companies I mentioned earlier, real-time rendering and rendering are applicable to basically every industry where there's a graphical interface of some sort. So I think it's cool to have that kind of flexibility and apply, my skills in a variety of industries, which I do hope to do. And then Gio asks, what is the best way to support the animation industry without being involved with it? That's a good question. I don't know. I would say enjoy the arts, continue to, continue to follow like and appreciate what kinds of technical innovation and artistry go into the making of these 3D films. And I think it's just, I think it's really interesting to follow how technology drives art, drives technology, and see the progression of this industry as a whole. So I would say just by being, patron of the arts and going and enjoying these films, you are supporting the industry. And yeah, that's pretty much it. All right, since we're at 9 and doesn't look like we have any other questions, thank you guys so much for joining and have a good night.
Thanks, Shubha. That was so solid. And thanks to everyone for coming out. We'll be uploading this recording to the MDB channel. So yeah, thanks again.